Hi class, today you guys are going to learn how to solve for separation or explosion momentum problems. I've got 3 examples here. I'll work through them and then you should be well on your way to solving the rest of the problems for your assignment. The first problem says here on the top, example number 1, that a 10 kilogram cannonball is fired to the right at 100 meters per second. The cannon has a mass of 200 kilograms. How fast will the cannon be pushed left by the explosion? So what you guys should remember from Newton's laws is that every action has an equal and opposite reaction. So if a cannonball is launched forward, then there's going to be an equal and opposite reaction backwards. Now, because the cannon is so much heavier than the cannonball, you're going to have a really big velocity with the cannonball, in this case 100 meters per second, and the cannon itself, which is 200 kilograms, is going to be pushed back the opposite way, but much slower. What makes these problems so easy is that initially the object is at rest. Now, I didn't say that, it's kind of just assumed. I'll make sure on a test or a quiz that I put that the object is initially at rest, which means with our momentum formula right here, that the initial velocities for both objects are just 0, which makes it super easy because all we have left are the 4 unknowns on the right. Now we'll go ahead and fill these in. I'm going to make the 10 kilogram cannonball M1, and it gets fired to the right at 100. And then I've got the mass of the cannon itself, and then the velocity that gets pushed back, which means we have 0 equals 1000 plus 200 VF. And then you go ahead and you solve by moving 1000 to the other side and dividing by 200, and you should get -5 meters per second, which is much slower than the 100 meter per second cannonball, which is what we expected, and it's negative because it's moving to the left, the opposite way of the cannonball. Alright, example number 2. A 40 kilogram student sits on a frictionless cart in physics class. The student pushes a 5 kilogram bowling ball forward at 8 meters per second. How fast will the student be moving backwards? Okay, so this is like one of the carts we have in class. I'm actually just going to have them stand. The surface is really smooth. They have some sort of a bowling ball in front of them, and they push that bowling ball forward at 8 meters per second. And then they themselves on the cart are going to move back slowly with some sort of speed. And that is our unknown. Alright, well, this is an explosion problem. They're initially standing at rest with the bowling ball, so that's 0. We've got a 40 kilogram student on a cart. We don't know how fast VF they're going to be pushed backwards. And they push a 5 kilogram bowling ball forward at positive 8 meters per second. Now we've got it set up. We've got to solve for VF, so I would bring over the 40, the 8 times 5, so -40 equals 40 VF, and VF should equal -1. Again, it's negative because the person is going the opposite way as the bowling ball. Last problem. We've got a firework that's sitting at rest before it explodes, so here's some sort of a firework sitting there. I don't know how to draw a firework. Maybe there's some sort of a wick or something like that. And it explodes, and all of a sudden 0.3 kilogram of it, so maybe this much, flies off to the right with some speed, and the rest of it flies off to the left. Alright, well, it's initially at rest, so those are both 0, and it looks like 0.3 kilograms of it explodes to the right at 2.5 meters per second, and the other amount, which would be 0.7, which would add up to the 1 kilogram here at the beginning, that flies off to the other direction, and I'll put that as VF. Now I'm going to go ahead and go to my calculator and solve for this. So 0.3 times 2.5, I'll bring that to the other side and divide by 0.7, and I'll get -107 meters per second. And the question always also says, what direction does that piece move? Well, The 0.3 kilogram piece went to the right, which means that this piece is going the opposite way because it's negative to the left. That is how you solve separation and explosion problems. Thank you very much.